Hi everyone! Today we're gonna talk about brushless motors, and before starting I would like to talk about why brushless motors. And here you see the table, and in this table I put some brushless motors and some stepper motors to compare them. So here is the name, type, power, torque, weight, RPM, reduction ratio which is needed to be applied in order to have 60 RPM, and which torque you can get at 60 RPM. Why 60 RPM? Because for me it looks like a decent speed for the robot arm. So, from this table you can immediately see that for the brushless motors, the power of the brushless motors is quite high and the torque is also quite high, especially if you account this torque and RPM. So the maximum torque which you can get at 60 RPM from these motors, it's significant. Even for the very light motors, like 80-gram motors, you can get like 80 Newton meters torque, which is incredible. And with respect to the stepper motors, their torque is quite low, they're super heavy, they cannot spin very fast, but this is actually advantage because these stepper motors, they don't need a high reduction ratio. But also the torque which you can get is not so high. And even look from the stepper NEMA 23, which weighed 1.2 kilogram, you can get only 38 Newton meters. And the same 38 Newton is kind of not the same, but you can get almost 2 times higher torque from the brushless motor, which weighed only 80 grams. Of course, you would need to add the weight of the reducer, because here you would need a reduction ratio of 132 instead of just 20. So as you can see, the brushless motors, they look like more powerful, less weight, but at the same time it's more difficult to work because you need a high reduction ratio. For the stepper motors, they're heavy, they're not as powerful, but you don't need the high reduction ratio. Why this line in red? Because I have this exact motor from ODrive, and in this video I'm gonna test this motor with the ODrive controller. Here there is all parts which is needed in order to run brushless motor. So this is brushless motor itself, controller for it, and this controller is rated for the 24 volts and can drive 2 motors, 1 and 2. There is also encoder, which gives the position of the motor. Encoder connects to the controller with this cable. We also have a resistor which dissipates the power during the braking of the motor. This is cables to connect the motor to the controller, cable to connect the controller to the computer, and finally power supply. So now let's assemble all of this. Let's start with the controller. Now let's connect the motor wires. Braking resistor. And power supply. Now the controller is more or less finished. Let's continue with the motor. Next is encoder. Our shaft diameter is 8 millimeters, so we need a blue spacer, this one. First of all, these two. This one. This one goes on top. Now this part. And now this one goes on top, like this. I disassembled the encoder in order to change this screws, because this screw is quite thick and I cannot adjust the exact position. So this is smaller screws, as you can see here. So with this one it should be much better. So now it's in the center. Now I can tighten the screws. I changed these two screws. Before I had these ones, which has a quite big diameter, and now I installed the smaller ones. So I installed screw and nuts. And with the smaller screws I can adjust precisely the position of the encoder. So I install it in the center as good as I can, and now it sounds much better. Now we don't hear any sound of the friction. Now what is left is to connect the motor to the driver. So first of all, the encoder is going like this. This one goes to the motor 0, this one. Okay, 5 volt is actually yellow wire. So, and the motor itself, just these 3 cables. 1, 2, 3. Now what is left is to connect computer to the driver with this cable. Now let me rearrange the table. To control ODrive I will use a Raspberry Pi. So this is Pi itself over here, and it's connected to the 7-inch touchscreen. So let's power it on. When it's powered on, let's install this small piece. Nice. Let's start with Raspberry Pi. So first of all, command line sudo apt get update. Next sudo pip 3 install ODrive. Successfully installed. Now let's go to the ODrive web page. Documents. Getting started. Downloading and installing tool. So we need this line. Done. So I just copied these 3 lines from the Linux installation part, and now we're ready to start. So I switched on the power supply, and now let's try to start the motor. So first of all USB. To start ODrive tool, just type ODrive and enter. So let's do this. ODrive tool, enter. ODrive tool, enter. So to test it, let's try ODrive 0.v bus underscore voltage, enter. So this command, let's copy it. Oh, 24 volts, perfect. Looks like it's working. Now let's do the calibration sequence. Like in the startup guide. Copy, Raspberry Pi, edit, paste, enter. It rotates, looks. Nice. So it's working. The next step, we should put ODrive in the closed loop control. Now it's super difficult to turn it. It's strong actually. The next command is position control. So position set point 10,000. Go. Position set point 0. Go. Aha. Position set point 20,000. Go. Position set point 0 again. Go. And it's coming back at exactly the same place. Nice. Let's now play with the velocity limit, because I think it does not rotate fast enough. Okay. So let's put this into the command. Okay, let's make velocity limit 1000 counts per second. I don't know if it's a lot or not. Let's try it. And let's go now to the 1000 to 10,000. So it should be really slow. Yeah. And it's going by steps. Velocity limit 200,000. Nice. And it's still quite cold. Perfect. Now when we know how to use the ODrive controller and brushless motor, let's connect to the brushless motor something more interesting than just a ring. And for this I have this massive gearbox, planetary gearbox. It's super heavy. This gearbox has a reduction ratio of 32. So it's quite nice. Okay, set point 500,000. Set point 0. Nice. The next step is to control this brushless motor through the ODrive with the Arduino. So I already connected the Arduino, and here the blue wire is the ground, the green wire is the transmitter from the serial 1, and the yellow wire is receiver from serial 1. And it goes to the ground to the ODrive, and the yellow wire goes to the GPO1, and the green wire goes to the GPO2. Now we need a library for Arduino. For this we can go to the GitHub of the ODrive over here. So this is a folder with the Arduino code. We can download it. And inside this folder there is all these files. But what we need is Arduino folder and ODrive Arduino. So we need to install it as a library for the Arduino program. So include library, add zip library. Here we should show him the path to the ODrive Arduino. So where is it? Yes, choose. And now when it's installed we can go to the examples, and in example we see that there is ODrive Arduino and ODrive Arduino test. So we can use this program to test Arduino connection with the ODrive. So this is a small program which I wrote. It uses ODrive Arduino library. So everything is connected to the serial 1. So we initialize the serial 1 and serial. And here we set the velocity limit and current limit. This is the calibration sequence. And in the main loop we have a set position to the 200,000, afterwards set position to 0, with a delay 5 seconds between them, and afterwards we do the same move but faster, with a faster speed. So first we switched on the power for the ODrive, and now we put the power for the Arduino, and just let's hope that it's gonna work. This is a calibration sequence. And so already started, you see that motor rotates slowly in one direction and another direction. And now the main program. So this is slow speed, and now it should be fast speed. Perfect, it works. Now we can control this beautiful brushless motor with the Raspberry Pi and with Arduino using ODrive controller. This should be more than enough for interesting projects. See you next time.